Okay, I'm waiting for Little Machine Shop to inform me that they have the bushing and key that comes with this, and they call this shaft B and C gears. So this is an idler axle, I would say, yeah. And the bushing, let's bring the camera to the picture. The bushing and key look like this. Now, it is 12 millimeters OD, 8 ID, 16 millimeters long, and the key is 3 by 2.3 millimeters. Now, when I ordered the shaft B and C gears, this hangs on the banjo. I'll show you where it goes. Okay, so basically it's right here. This is B and C, and it bolts up to this banjo. It bolts up to this banjo here, and these two gears are keyed to that. Yet they spin freely on. They spin freely on this shaft. So when I ordered this, I also ordered an 80-tooth gear, which I needed because I blew my first 80-tooth gear out, I would say, within the first 4 months. And when I did that, I basically destroyed all this structure in here around this keyway. So I had no idea how easy it is to order that. But nonetheless, I ordered these two items together. This one comes, this one says it's on back order. Okay. Now when I order the bushing and key, it just says out of stock, we'll contact you when. And I translate that to make your own. So, that's what this is all about, this whole machining thing. And although it's a very simple part, it'll certainly have its challenges for me, being that it has to be precise, and cutting that keyway might be a challenge as well. So I started working on the OD here. Now let me get my, I'll show you my drawbar. Here. There's my drawbar. This collar here is free, and it is beveled to go inside the end of the spindle there. And I have all this arranged so that it's all held by magnets. It's all magic. Okay, this is about 650 RPMs. I'm feeding this by hand. I may adjust then. I may have already exceeded my OD. Let me measure what I have here. Okay, I'm at 15.2. Or 15.19. Okay. It'd be just my luck that I would be Then I understand a little better how an electronic lead screw might work for threading and such. I think if I had an electronic lead screw, and if it does what I suspect it does, I would go ahead and get the 16-inch bed for this. Upgrade there, maybe put my treadmill motor on here. Kind of watching my clearance, seeing how close I'm going to be able to get. Okay, I can get as close as I want. Okay, that's... I don't know what that's about. I certainly did not touch my cross slide. Okay, I'm going to call that 0, and we can start measuring. What we're removing. The calibers are nice, but hell, if you're not holding it perfectly square, you're not getting a good reading. So I'm 575, 585, 587, a little over 587. Now I need to figure out what 16 millimeters is. Decimals. Okay, so it's 0.630. Write that down. 0.630. 0.630. So 630. No, that's not right. I'm only at 12. I need to know what 12 millimeters is. 12 millimeters is the OD. Okay. 473. That's a little heavy. Okay. Well, if I can get rid of this 1,000. I keep getting rid of that 1, and it keeps coming back. Oh, there it comes again. Okay. That's 472. That's close enough. $472. And where did I say we were at? Okay, it looks like I'm 475 plus 23, so I'm just 2 thousandths under what my target was. So let's do that again. Let's just call it 22. So there's 475, 485, 495, 96, 97, and 5 ten-thousandths. Am I reading that right? Hot tip here. Seems silly, but it's made a big difference putting a spring in here. This is my tailstock. Really reduces the catching and dragging and catching on the bedway. These are Easy Lab Diamond Hone & Stone. You saw me use that a little bit earlier. Okay, so we're at 500. We want 472. So we need to get rid of 25 thousandths. So I'm going to take 10. It's 10.5. Again, we're about 600 RPM. Okay, so that was 10. We were at 20, so that I should be at 70. What, 72? Okay, there's 472. And that is my number, 472. Let's see what we get with the dial calibers. I'm going to switch it to, I will keep it on. Okay, see, I'm getting 475 there, 12.7 millimeters. 12.3, let's go closer to the collet chuck here. 11.9. 12.6. We're going to leave it right there. We can sand that down to get it where we need it. So, I guess that's it for the turning. We will set up for drilling, possibly boring, and had a crash. Okay, we are back,
to actually do the grind.
and I have my largest metric drill bit. I already have a concave hole here on the end, so I believe we'll find our center reliably. And like I said, this is the extent of my metric drills minus 1, which I believe I snapped my 2mm. So here's 6, and I'm looking for 8. I'm not sure if I have a boring bar small enough to do this job. I may just have to find a letter or a number drill or a fractional drill equal to 8 millimeters. Go all the way through with those. Kind of thinking about how I'm going to do that keyway. I do have like an 1/8 inch end mill. Let's see how that measures up to keyway, which is a 3 by 2.3. Yeah, that's going to need some. I mean, it's going to be centered, I think, enough. Okay, it looks like I'm 475 plus 23, so I'm just 2 thousandths under what my target was. So let's do that again. Let's just call it 22. So there's 475, 485, 495, 96, 97, and 5 10,000ths. Am I reading that right? Hot tip here. Seems silly, but it's made a big difference putting a spring in here. This is my tailstock. Really reduces the catching and dragging and catching on the bedway. These are Easy Lab diamond hone-in stone. You saw me use that a little bit earlier. Okay, so we're at 500. We want 472. So We need to get rid of 25 thousandths. So I'm going to take 10. It's 10.5. Again, we're about 600 RPM. Okay, so that was 10, we were at 20, so that I should be at 70, what, 72? Okay, there's 472. And that is my number, 472. Let's see what we get with the dial calibers. I'm going to switch it to, I will keep it on. Okay, see, I'm getting 475 there, 12.7 millimeters. 12.3, let's go closer to the collet chuck here. 11.9. 12.6. We're going to leave it right there. We can sand that down to get it where we need it. So, I guess that's it for the turning. And we will set up for drilling, possibly boring, and ream. Okay, it turns out that 5/16 is just under 8 millimeters, 25 thousandths under. So I got an adjustable reamer I could probably knock out 25 thousandths with. Just kind of do that by feel. I'm going to use a little oil on this. Really wobbling a lot. With all that wobble, I might have my dimension. That may bring the part up here and see See if we've got a good fit or not. Okay. Well, I was going to quit this whole thing, probably an hour ago and go back to bed. But one thing leads to another and another, and I know I'm not going to be able to go very far, but I'm going to at least clear the start of that. Okay, that would probably press in, but that's not what we want. We want this to turn freely. So, what I have here is a 5/16 adjustable reamer. So, I'm not sure if I have enough depth to get in there all the way. Okay, I have enough depth. I can get in there all the way. And that was kind of zero adjustment, I think. The way you adjust that is to turn this. There's a flat on two sides of this, 180 degrees apart, and you twist that to draw a piece through there to spread those cutters. I think we might have a part here. I don't want to blow that too hard because I'm just going to blow the stuff back out at me. Okay, that's still tight. So, let me get some pliers. And make sure I'm going the right direction. I'm going the wrong way. Okay, let's try that. Okay, we picked up a little something there. Okay, not all the way. Okay, I think if I do a couple spring passes in there, we might have what we need. Let me take this thing in there a little closer. Okay, so let's try this before I do it. I think we were turning it this way. Okay, that was about one turn, I would say. Okay, we picked up some dust there. I want to say there's slight resistance, but not really. A little snugger than that. Okay, that's good. I'm not sure how I'm going to be able to part that. You know what? I'm going to bring that out a little bit and just see how it runs. That looks good. See, ordinarily that cullet would have grabbed that part. If it was 5/8, would have grabbed that part a long time ago. Yeah, that's going to be good enough. Let me bring in this piece here. I should stay with the same tool. Okay, I probably dropped down 1,000th or so, but I think that's going to be fine, because that key is going to be there. I can put that on the inside. In other words, this is a little recess down here. I can put that recess up against this shoulder, because all the engagement is out here. 16, I would say all the engagement is going to be the first 12 millimeters. So this will be going in on the other side. So I have my length, I have my OD, I have my ID. I need now my keyway. And we're just going to leave everything as it is, because I may be cutting my keyway with this. What I need to do is figure out a way to get this mounted on my tool post. Get an 1/8 of an inch end mill and run an 1/8 of an inch and run this up against an 1/8 of an inch end mill. So I have the end mill spinning on my chuck and have this piece mounted to my tool post somehow. Okay, we'll have to figure all that out.